Hello, Mr. Aaron, Mr. Ryan, alright?
Chicken fly.
What have we talked about yesterday?
Depth of search.
We are talking about the depth of search yesterday and the day before yesterday, yeah? On the day before yesterday, we talked about the recursion depth of search. We're using
Today
the
we're going to do
recursion.
about breakfast search.
Exactly. Yesterday, we talked about the iterative depth of search. We're using a stack, right? We're using a stack. We do this in order. So the idea is that we use the stack, we push the node and go to the left as much as we can, right? And then we take one out from the stack and we go to the right. So that will result in order. So the problem is that we're given two trees, yeah? One is another one's clone, and we're given a node in the one tree and we want to find the corresponding one in another node. For example, like this is a tree A, and then that's exactly the same copy of the tree A, but it's a clone, right? This is tree B. So if we are given a node in tree A, we want to find the corresponding one in tree B. We just synchronize. We have two pointers, so we synchronize. So we go to the left, yeah, we go down. For example, if we have a more node here, yeah, more nodes. Okay, so these two trees the same, yeah? So how exactly are we doing this? Look, depth of search, either in the recursion or iterative, right? So 1, 2, 4, look at my both fingers. They have the same movement, right? Yeah? Yeah? Okay, so because for example, this is 3 is the node we are looking for, and then we return 3. So yeah, you got it? So the depth of search, what's the order? 1, 2, 4, 5, 6, 3. But for the breadth of search, 1, 2, 3, 4, 5, 6. Okay, so for example, 6 is the node we are looking for. Now what should we do? We return the one on the right hand. Okay? Yeah, got it? Makes sense?
Yes.
And for the breadth of search, let's just quickly review what's breadth of search.
It's wet.
What's breath first? Don't say it's breath first, okay? Breath first.
It's when you breathe.
Yeah? Okay, breath. What's breath?
Is when you go in order. DQ.
Okay, so what's this word? Breath.
Breath.
As opposed to
Breathe.
death. What's breath? Why? Yeah?
Breath.
Why?
No, breath is this.
What's that? Oh, you see? It's okay, this is breath. Okay, sorry. It's breath. How do you spell it? Breath. Okay, so this is breath. Yeah, breathe. Yeah, but we are talking about the breath. So breath first. So basically, look, we have a tree. We want to go horizontally, right? Horizontally. So that's breath. As opposed to depth, we want to go deep as much as we can, right? It's just two different ways of traversing the tree, also the graph, right? But so how do we implement the breadth of search, BFS? Q, yeah, DQ, yeah. Right? Look, a Q equals DQ, yeah. Q, DQ, double NDQ, yeah. At the beginning, we can put a root in, right? Root in, which is number 1, right? Okay, so look, this is a Q. At the beginning, we put a 1 in. That's the initial. Okay, so what do? We take, there are two ways. We can take everything out, or we can take one node out. Both are okay. Yeah. So for example, if we want to take one node out, we take one node out. First in, first out. Yeah, Q. What's the kit of 1?
2 and 3.
2 and 3. And a pen, I push it to the Q. Okay. Now, okay, I can take everything out, or I can take one node out. What's the next node to come out from the queue here? What's the queue? This is the 2, yes, because first in, first out, yeah. So it comes this way. This is in queue. We put a node in it, and this one is BQ, means to take it one out. So we take 2 out. What's the kit?
4 and 5.
Okay, and then push it 4 and then 5. Okay, and then what's the next node to come out from the queue?
3.
Okay, what's the kit of it?
6 and 7.
6 and 7. You got it. And then we just take a 4 out. It doesn't have any kit. Take a 5 out. It doesn't have any kit. Take a 6 out. It doesn't have any kit. Yeah. So that's the order of the breadth of search. Okay. Yeah. I was just taking one node at a time. We can also take all the nodes. So what's the difference? You tell me. Okay. So look, no one in there. Yeah. No one in there. I take everything out. Which one? And what's the kit? That's a 2 or 3. Okay. I was taking 2 at the time. Now I can take, if I take 2 and 3 out, what's the kit of 2 and 3 in order? 4, 5, 6, 7. Okay, so you see the difference. Do you see the difference? If I take everything out, I can be assured that all the nodes at any time in the queue belongs to the same level. Am I right?
Yeah.
We given these two trees A and B, and how do we use the breadth search to solve this problem? To solve this problem. This is tree A, yeah? This is tree B. So tree A is like this, yeah? So look, tree A, tree B, exactly, copy. So every time we have a queue, we push the tuple of A and B, right? And then we push the tuple of A and B, and we just check if the node equals to the tree A, then we return the second parameter in the tuple, which is the tree B. Okay. Q define breadth search A B target. Okay. Q equals DQ. At the beginning, we push the root, which root is what? A and B. Yeah. So what? A, B, can you tell me what's this? What's this mean? Tuple.
Can't change.
That's right. Oh yeah, immutable can't change. So look, this tuple has 2 elements. The first element of tuple is the node from the tree A. The second parameter is the corresponding node in the tree B. Okay. And then now look, Y up Q. So we can get the length Q, and then we take everything out of the Q. DQ in range n. Okay, and then look, x, y equals q dot top left. Okay, we take a node out of the queue. First in, first out, or the top left. Okay. If x is t, right? If x is t, we talk about this is and the double equal sign, right? Ryan, Eric?
Yes,
So what's the difference between if I use the is and what's the difference if I use the a? So for example, a equal b. What's the difference? A is b. What's the difference?
A is B.
Which one is the value? We check the value. Which one is check the identity?
I think the value is equal.
Yes, and this one is identity. Okay. So basically, this one identity is ID A equal ID B. Okay. This is the equivalent. Okay. A equal B is the value check. For example, like A equals 1 2, B equals 1 2. These are 2 different arrays, but they have same content. The values are the same. So A equal B. It's true. A is B. False, because they are different. Right? But if A equals 1 2 and if B equals A, then A equal B, true. A is B. Is it true or false?
Yeah.
Yes, because B equals A. B is an alias. It's the same as A. It's just different name. Okay, so if X equals T, then T is the node in A, and then we return Y, right? Look, because X and Y are the corresponding node, right? X is the node in the tree A. Y is the node in the tree B. If X is the node we are looking for, then we return the corresponding one, which is Y. Okay, and then we just have to do this. If X dot left, then we just return. We just push the kit. Yeah, Q dot append X dot left, a tuple. Yeah, X dot left, Y dot left. And can you tell me what's missing here? If what? Look, we're checking the left tree. If they are left tree, we push the left tree into the queue. Yeah, if X dot right, Q dot append X dot right, Y dot right, right? If X dot right, Q dot append X dot right, Y dot right. Okay, that's a tuple. Yeah, time complexity. If there are n nodes, what's the time complexity?
N.
Yeah, O(n). Because look, there are n nodes. So because each node we visit once. Got it? So that's O(n), right? What's the space complexity?
N.
Yeah, why is that?
DQ.
We're using a space to store the nodes. What have you learned today?
We're learning about breadth search.
Yeah, we took out 2 trees. We got a
Trees.
yeah.
And they're basically the same thing.
Yeah, and then
The problem is There's two trees that are the same. Number one that's in the other one.
Yeah. And we're using the BFS search. Okay. So to sum up, we are given two binary trees. Yeah, A and B. B is a clone of tree A, and if we are given a node in tree A, we want to find the corresponding node in the tree B. Right? Remember what's this? Look, two hands. Yeah, BFS search. 1, 2, 5, 3, 4. Okay, 4 is the node we are looking for, and then we return this one. Right? And BFS search as well. 1, 2, 3, 4, 5. Okay, 5 is the node we are looking for. Then we return the right hand. Okay, make sense? Yeah. That's it for today. Bye bye.